This is the laminar boundary layer flow 2D simulation for lab 4. So we're going to take our wind tunnel from before and we add our flat plate with the correct dimensions. And then we're going to import it into fluids. Just make sure that it loaded in properly, and then we can close out of this. We're going to go edit the mesh. First, going to insert a new method. Select the body, change it to triangular or triangles. You want to put this as small as your computer can handle, but to speed the video up, I'm just going to keep it normal. I'm going to insert a sizing. Select on the edge selector. Select all 4 edges of this. And then hit apply. We're going to change this to number of divisions and then turn it to 100. And then while we're here, we're going to name these edges as well. I name them flat plate walls. We're going to name the inlet velocity inlet and the outlet as pressure outlet, and the rest of the walls as walls. Just going to generate the mesh again real quick. Oh, we're also going to add or insert inflation. Select all 4 edges of the flat plate. We're going to go to about 5 layers. See if that works. Cool. And then we're gonna do the same for the rest of the walls besides the inlet and outlet. Sure. So that's what it should look like when you're done. We can close that. And we need to update the mesh. We're gonna go edit the setup. 2D double precision, display mesh after reading, and then start. Okay, so we're going to make sure that the fluid is air. We're also going to make sure for models, we can edit that. We want to do K epsilon, enhanced wall treatment, and add pressure gradient effects. Then for inlets, we're going to change this to the inlet velocity. For reference frames, oh no, this is the wrong section, sorry. We are going to add a new force report for the drag force. Now we're going to go to initialization. First, we're going to change this to 25 iterations. Then we are going to hit initialize. And we're going to hit run calculation. Set the iterations to something large. We're going to do 200 to be safe. It should usually take around 50 or 60 though. Then we're going to hit calculate. Okay, after that, we can go to graphics, contours. We're just gonna make a velocity contour to see how everything looks. Looks pretty correct. So we're gonna do part B first, plotting the laminar boundary layer velocity profiles uh, at 3 locations. Oh no, sorry, we're gonna do a part D first. And we're gonna write to file. And then you're just going to export that or import it into Excel and plot it. And that's for part D. Okay, so now we're gonna do the rest A, B, B, and F. So we are going to quit. We're gonna open up results now. Okay, so for the velocity contour, we select symmetry 1. What we can also do is equally spaced and then hit 100. Actually, I think vertex is better. You can really see the direction. And then you just line it up, save picture, export it to wherever, and then you're done with that. I'm also going to insert 3 lines. One is, I'm going to call it line 1, 0.2. It's going to be negative 0.15, 0.3. I'm gonna do this twice more for 8 centimeters and 16 centimeters. It's gonna be at 0, 0. Actually, it's gonna be negative 0.035. And now we will insert a couple of charts for these. This one we're going to insert line 1, velocity on the x-axis, y as the y-axis. And there's that. Then you can export the data as a CSV, import that into Excel if you wanted to. You just do the same thing, same process for the other 2 locations. And that is for part B. And we've already done part D, now for part E. And for part F, we got to go back to the results or the solution. We're going to XY plot. Skin friction coefficient. Write the file. Actually, we're just going to plot this right now. There's that. It should look similar to the wall shear stress graph from part D. And it does, so that checks out. For the drag force coefficient, we can go to the drag force file here. We can export it as an out file and import that into Excel. And from there, we can graph it. And that is it for this Google project.